Yeah, so I start out by saying chaos because to some degree that's what we are living in. And it's going to get worse and worse until the singularity happens and we don't have to worry about anything anymore. But that's kind of what we're living in. And so the question is, how do you accommodate that? I've already spent a little time talking about myself. Again, the key thing is I tend to be an early adopter of newer technologies, which means a lot of things I talk about may not be appropriate for you right now. But chances are next 3 to 5 years, this will be something you will be living with as well. So don't feel strange if, for example, this doesn't seem to make sense to you or you never use that in your business yet. So I want to start back, because I'm old, we start back and remember a simpler time, the 1970s. So this is an IBM 1130. This was the third computer I actually worked on. It had 16K of 16-bit words. It was actually core memory, the little metal donuts with little wires running through them. We did price out the additional 16K of memory for this. It would cost us $100,000. We decided we didn't need it. But this was a simpler time for a lot of reasons. And unfortunately, a lot of things that went on then are still being carried today. Because back then, basically, we measured our size of our projects in boxes of cards. Now, how many boxes of computer cards is this project going to be? And I don't see anybody quite old enough to remember how many cards are in a box of computer cards, but there were actually 2,000. So a giant application was 4,000 lines of code. And that sort of colored our thinking and processes back then, and those have been carried forward. So by the way, you could actually take that much code and sort of inspect it and do code reviews and probably run some tests against it and be pretty sure it actually works because it's just 4,000 lines of code. But the really nice thing about it is it ran in its own little world. There was no outside world interfering with this program running. It was all run on this machine. This machine was not connected to anything else in the world. Your program was it. It was its own little world, which is a very safe place to run in and very easy to run that code in. And again, a lot of our processes came out of this sort of era. This is how big things are. We can test things. We can make sure it works. And we can test it in our special environments. Now, of course, the reality is, with the new millennium, that programming is much more difficult than that. The environments are quite a bit different. Of course, now we got tens of millions of lines of code in the enterprise. And that probably doesn't count the operating systems they're using from third parties. And we think we can test. In fact, we still try to test. We got a lot of new techniques for that. We got processes like TDD associated with that and BDD. We got some new tools that are very powerful for doing this sort of work. And we got these ability to build these huge environments economically to sort of test our code in. And yet, we will still have bugs, and they will still be your fault. And primarily because I can't figure out all the bugs when there's this much code. And by the way, there will also be bugs that are not your fault. That are maybe because APIs have changed or some service went down. And a lot of times you can't tell which of these two it happens to be. So this is the world we're kind of living in right now. And to some reason, the process associated with the 1970s that emerged out of there, sort of the waterfall stuff, we're still trying to apply it in this world, and it's not really appropriate. So how do you sort of cope with this, sort of in this reality of this world? Well, first of all, you try to break this 10 million lines of code into lots of other things. So a lot of the service-oriented architectures are trying to bring things down into smaller pieces, where we got it back down to something we think is reasonable and manageable. And I can sort of put my head around that. Or we try to use existing frameworks to handle those sort of situations as well. We've gone to event bus architecture so we can keep track of what's going on in live time rather than just have data associated with it. And that actually helps us figure out when things go wrong quite a bit easier. Obviously, we have cloud, so our scaling is now can be done in the cloud for us. And so we try to get rid of that problem, which is a nightmare about how much machine time do you need, how many machines do you need to install. Those questions have gone away with the advent of the cloud. Finally, you're doing a lot of more active monitoring of the live system. That we now recognize that the system is complicated. It will, in fact, fail. Sometimes our fault, sometimes external fault. So we're spending much less time doing acceptance testing and a lot more time building into our system active monitoring of the system itself. It's not that there's any less effort associated with doing it versus acceptance testing. It takes the same amount of effort to do that, but we want it running all the time in our running system. So that's kind of a change in philosophy here. And finally, we're going to be to start designing for systems to automatically recover for themselves. And this is where basically chaos engineering comes in. It says, let's build our system from an architecture perspective and put our process in place so that we can constantly check our own systems and make sure they're still running. And so that we know first that these systems are failing. So we call that chaos engineering. The chaos engineering guys sort of claim, and they admit they're experimenting on a live running system. And that's perfectly acceptable to them in their philosophy. Because the worst thing that would happen is, yeah, our customers are experimenting and we don't know it happened. So this is a core principle behind that. And again, you know, if you look at a high art form of chaos engineering, you have to look no further than Adrian Cockcroft and some of the philosophy at Netflix. And how they have the Chaos Monkey, which is, you know, a little script that's kind of one of those famous little scripts in the world that just kills services randomly to see if they come back. All the way up through the Simian tree, all the way up to Chaos Godzilla, where they literally knock out an Amazon region and see what happens. Now, it turns out they don't actually turn off the regions because Amazon doesn't like that. But they kind of block, logically, the region from the rest of the world and see if everybody still sees their movies. So that's chaos engineering. But what about chaos in development that's going on? Because I can tell you from my experience across all these years, requirements are always changing. We're always getting that. So I sometimes ask my audience, you know, what happens? How do you handle changes when you come in? And I get a few guys once in a while say, we don't need changes. We know what we're doing. And I basically call those guys liars because that's clearly not true. At best, you could call them naive about that. They don't know what's really going on. And then I have people say that what changes? We don't, what about this? And this is people in organizations where the changes get hidden by layers and layers of business people and managers, but they're basically still changing all the time, and they just are worrying about what they have to worry about today. Those companies don't do very well either. So those are kind of the blissful ignorance people. And finally, you have the people who say, oh, we have a backlog, and we do change management. So we have a list of all these things, and we look at them regularly, we reorder them, and we decide what we need to work on next, and we can handle all these things. I'm not a big fan of this because I think to some degree it's always changing. I think going back and reprioritizing old requirements again and again is a large waste of time. So to some degree, it's sort of a futile attempt to control this with management processes. I think what you have to do is accept changes are going to happen. The same way we accept that in more complex systems today, that our engineering systems are that way. We want to accept the fact that from a process perspective, from a development perspective, our customers are always going to be changing their mind. So how do we accommodate that? What do? We want to accommodate this sort of concept. And we need to do that the same way we did with chaos engineering. We're looking at some architectures and processes that we should be building on around that. So I kind of would draw this chart for actually quite a few years now. This goes back to around Y2K when I started drawing this chart. It talks about some level of degree of certainty and uncertainty associated with requirements. To some degree, if you know exactly what you want to build, waterfall actually does work. You know, I developed systems for decades around waterfall processes. We delivered systems on time that did exactly what we said they would do. And that's because to a large degree we understood what we're trying to build. But as things got a little fuzzier, Agile actually kicked in really nicely here. So if a customer understands kind of what they want mostly, and still has some ideas about what they may need later, but they're not quite sure about that, as long as they're sure about something, I can get started. And that was a very powerful change in the process. And so Agile works really well in that environment. But in this time frame, though, when a customer walks in and says, I need a system, well, what should it do? Well, I have some ideas about it. Well, what sort of ideas? Well, it could do this or it could do this. You're like, well, what should it do? Basically, at this point, if you ever try to do these systems, you're doomed to failure. Yes, you might deliver something, but it's probably not what they need in the final result. Traditionally, actually, about 2 out of every 3 projects fail in software, and mostly because they're sort of sitting in this zone here. So if I find a system that's kind of like this, I kind of walk away. It's not worth my time because we will fail. So, rolling into now, I kind of now have a better idea that maybe I can actually solve some of these problems. Because some of these problems are actually what I call fuzzy problems. So you're going to get a chance tomorrow morning to hear Dave Snowden talk about the Cynefin framework. And I would highly recommend you listen to him. It's been one of the most influential things that I've seen in the last decade about how to think about my customer situations. So one of the things that Dave Snowden will talk about is there's there's types of problems. There's simple problems where the cause and effect relationship is very straightforward. I flip the light switch, the light comes on, turn it back off, it goes off. Then he says there are complicated problems where there is a cause and effect relationship, but it's much more convoluted. So it takes somebody who really understands the domain to really understand those relationships. But he doesn't stop there. This is where it gets really interesting. He said there's also chaos and complex domains. A complex domain is where there's a cause and effect relationship cannot be discerned. You can't figure it out. Yes, if this happens, you can figure out why it happened, but it doesn't help you project the next time, because the next time this happens, you may get a completely different result. So it turns out this is the way markets work. This is all your financial markets are sitting like this. This is also the way that tends to things like Google advertising works, or questions like, should I loan you money, or what book do you want to read next? These are all fuzzy questions, and they fall precisely into this sort of domain. One of the problems is, of course, you actually want to organize yourself differently for each one of these types of problems. In other words, one size does not fit all. If you have simple problems, this works really well. You put a manager in place, he teaches you best practices, the employees implement the best practices. This actually is the correct structure for that sort of problem. Then when you have a complicated problem, you got to find those experts, the people who understand it. So these people can then, of course, they're expensive, so you want to leverage them in some way. So basically what you do in this case is you hire a team, and basically the job of the manager is to feed the information from these guys into the team and get the work done. So this is basically almost traditional Agile, where these are the guys who write the stories, and the stories are handed out to the team, and the team gets the stories implemented, and we track the stories. And by the way, this is the right structure to handle these sorts of problems. But when you get to complex problems, the problem with complex is there is no expert. By its very definition, nobody can tell you what the cause and effect relationship are. In fact, if you have somebody who claims there's an expert, you bring them in, you pay them really well, and after a while you realize he doesn't know what he's doing. So you hire another expert. He doesn't know what he's doing. So then you fire the manager, because somebody's got to be to blame for this. But the problem is, of course, it's a different type of problem. It's the one that does not have that sort of nature to it. So in this environment, you basically want to turn people loose saying, solve it. And there's really no role for a manager in this world, because there's nobody sort of to tell you what you're doing and doing right or doing any time, because there is no such metric. And there is nobody saying, I'm the expert, I can tell you what to do. So there's a different type of organization for each one of these. So now I'm beginning to believe that, that zone I used to call, the graveyard here, is actually now the fuzzy problems. And they are kind of viable, but they use different techniques and technologies in which to do that with. And that's kind of one of the things I want to explore. So requirements are changing in all of these environments, not just this one. And so basically, these are radically different problems, and you really need two different approaches to attack that. So we're going to spend the rest of the presentation basically talking about an approach to more traditional problems that I tend to follow, and then I'll talk about an approach I tend to follow for the fuzzy problems. That's quite a bit different. So we'll start out with the more traditional problems. So I call these things chaos development, to steal the chaos engineering idea, to basically say we need to have a process and organization that accommodates changing requirements instead of trying to ignore them. I have a colleague and clients in London. It's actually a retail firm, and they have a concept of having all these things. They recognize they have all these different problems. They have a very traditional system managing their retail operations, supply chain, billing, and the like. They also are making changes to that system in sort of a very Scrum-like fashion. And then they have some really crazy things they're doing on the retail floors, very fuzzy problem sort of things. They have 3 different organizations with 3 different processes. They recognize this is different. All right, so almost all my principles of all these processes are all guided by sort of these principles. I like this list from Kent Beck that is about feedback, communication, simplicity, simplest possible thing that works, courage, the ability to sort of step out there, do what you think is right, and respect, saying that basically everybody's working for the good of everybody else. Nobody's trying in here to try to mess us up. So for traditional problems, I think Agile processes, especially sort of extreme programming sort of Agile, works really well. And this has been my experience to date. So this is actually Nationwide Insurance, one of the large insurance firms in the U.S. I can talk about them because they published this result. So they actually were working in a very traditional fashion, had a very traditional application, and they wanted to they basically wanted to rewrite that application. And they got a bid from their vendor basically saying it's going to take me 12 months. It was an offshore vendor, so it cost them only $28 an hour for the labor, and it would cost you $2 million to get the system redeveloped. And that was kind of a reasonable price in mind of Nationwide, but the $28 an hour was okay. But the problem was 12 months was too long for them. If they waited 12 months, they thought they would lose so much market share because the existing system was so bad that they'd basically be out of the business. So they're desperate, and desperate clients allow you to do crazy things. So basically, we went in there and said, let's do it Agile. We'll deliver the entire system in 8 months, but we'll actually give you interim releases so you get a chance to roll this thing out more aggressively and start using the aspects of the system much earlier. And I think the initial 3 months was putting something in place for the call centers to support the operation. And then at 5 months, we built the replacement system. And then at 8 months, we had all the extra bells and whistles they wanted. Our problem was our labor rate was quite a bit higher. We were 3 times the labor rate of the Indian firm. Now, the client, of course, wanted a fixed price bid. They always want fixed price bids. And so you're looking at this and saying, well, I got to develop the same thing. And by the way, these guys are CML level 5. They're really, really good at delivering. And they think it's going to take 12 months and at this labor rate. So what are you going to bid for this thing? Because you have to basically do the same job. And so you might say, well, since my labor rate is 3 times higher, maybe I need to bid 3 times as much and hope they're really desperate enough to want to pay that. Or maybe you decide we really kind of want to steal the business, so let's match the bid and say we can give it to you earlier. Or even maybe want to underbid just a little bit to try to steal the business. But by the way, no pressure on us, because if we get this wrong, we bankrupt our company. So it turned out our bid in this price was actually, we bid $1.1 million, and we made money. So basically, we were half the price, 3 times the labor cost. So we were basically 6 times more effective than the best CML level 5 company in the world. And this is using some of the techniques I'll be talking about. Now contrast that to this number. By the way, this is a Forrester report. It's been published. Forrester actually reported that this was a 4% ROI at best. The ROI on this project, mostly because you're delivering earlier, was 94%. Which means basically you're printing money. You've got to do this project at that rate. With the 4%, you might as well leave your money in the bank. So 13%. This number comes to us from one of the large consulting firms in the U.S. And basically, it's their estimate of how productive Agile is over traditional. They're looking across their customer set. Their customer set is 13% more effective. I got 6x. What's going on here? I heard Jeff Sutherland speak at one of these conferences a few years ago. And he said he's never had less than a 4x increase when using his process. I believe him, because I think he's thinking about the overall process quite nicely. Whereas most people, when they're, quote, doing Agile, they're saying they're doing Agile, they're bringing in Scrum Masters, but of course they're still doing Waterfall. I've had people say, well, in this Scrum, in this particular iteration, or this sprint, we will actually do our design, and the next 2 sprints we'll do our detailed design, and then the next sprint we'll write our first code, and then the 2 more sprints we'll test it. And they call that Agile. Of course, it's really just another name for Waterfall. But so what's the difference between these 13% guys and what we're getting in 6x and what Jeff Sutherland gets with his 4x? So why is that different? Well, first of all, you got to think about Agile from the ground up as being a different sort of process. You can't sort of shoehorn this into an existing organization with their existing attitudes. So the first thing you got to recognize is we want to move away from this concept of it's an engineering process, move much more into the fact it's kind of based on the manufacturing, the just-in-time thinking. You also want to move away from these Gantt charts, which people love their Gantt charts. Here's what's going to happen, here's the date it's going to happen, and it all marches along very nicely. We want to move into thinking about more like work in progress. What's happening right now? What do we need to be working on? And we want to move away from thinking about starting is important. Starting is not important. Finishing is important. A lot of times we fool our clients by saying, oh, we've started working on your element because it's really important. When in fact they should be asking, when are you going to finish? What's going to get finished? And so you wind up with an enormous amount of stuff that's sort of half done in the process. You want to redirect that. The other thing about Agile is every story sort of implies that it's easy to make the next change. If you listen to what the guy said about the original Agile, is about a story can be played in any order because I can take the next story and just do it. I don't need to keep backlogs and prioritize the backlogs and see everything up front. That's sort of waterfall. So where did that come from? I mean, why do they think that? Because to some degree they're thinking that very first story is greenfield. That's a virgin system you're building with that first story. But every story after that means you're changing your system. And so these guys that came up with this process got really, really good at changing because that's the way they treated every new story. We're changing our system. And they made sure the systems were very, very easy to change. This grew out of the fact of a small talk team in Tektronix. Ward Cunningham was the lead of that team. Kent Beck was on that team. Rebecca Wursbrock was on that team. Sam Adams, quite a few other notable people were on that team. And they came up with a particular programming style that accommodated this easy changing. So the philosophy was, I want to be able to write code that can change. And that becomes our mantra for everything we're doing. Is this going to be easy to change this code? So this is what one of my mentors in this process said. This was an IBM back in the day. Rick DiNatale was one of the early guys in the OOPSLA conventions. And he basically said, object-oriented programming is only good for programs that change. So this particular style of programming I advocate is object-oriented programming. There are other styles. There's functional programming, some other things I think are very powerful for classes of problems. But for traditional problems, I usually dust off object-oriented programming and do it the same way the Tektronix guys did it back in the Smalltalk days. So to see how this worked, going back to Nationwide, so this was the legacy application that was at Nationwide. It was done in Java, the Oracle backend, web front end. So when we did the rewrite, our technology stack was going to be Java, Oracle, and web front end. Same technology stack. These guys had modeled and found 72 Java classes describing this particular situation. When we finished our model, we had found 1,400. This was a different style of programming. So it's a very strange style, but it's not magical. It's been talked about. It's out there in the books already. So originally, I got a lot of these ideas when I was doing my small talk from a book from Kent Beck that basically described the programming techniques associated with this school of small talk programming. So this is a small talk best program practice. This came out 3 years before the XP book came out. The XP book described the process associated with that thing. Well, for some reason, the two books went two separate directions. They should have always been bound together. So this is the process, and here's the techniques that make it work. We kind of missed that out. Now, unfortunately, some rewriting of this book. Martin Fowler, who's here this week, Martin has written now 3 versions of the refactoring book, one for Java, one for Ruby, and now the latest one at Christmas came out was JavaScript. But basically, it's almost a rewrite of the Smalltalk best practice patterns. It describes this particular style of programming. How do you make this absolutely gorgeous code that's extremely easy to change? And Martin has almost 200 recipes in there about what do you do to make code look really clean. There's also this style is now described in a book. Actually, it's in the second edition by a lovely woman, Sandy Metz, out of the U.S., describing this type of programming. Now, she uses Ruby as her language, but the style of programming doesn't matter which language you're doing it in. It's a style of programming. So the information is actually out there. And it actually is captured in the Agile practices. The Agile practices talk about simple design. And simple design is kind of, you go down what it really means under the covers, it means, first of all, the code works, which is good, it should work, but it also communicates. It screams out what it's trying to accomplish. If you feel a need to write a comment, there's something wrong with your code, fix it. That's what Martin's recipes are all about. Then make sure you get rid of all that duplicate code. Most people have that rule. Let's get rid of the duplicate code. But be very, very aggressive about that. Even half a line, I want to tease that out. And then get rid of all the extra code you don't need. Don't leave it lying around because it might be useful in the future. Clean it up, make it as simple as possible. And make sure you do this for your tests as well, because tests can get equally ugly. Now, the problem is, a lot of times, of course, simple is not the same as easy. There's a lovely presentation by Rich Hickey, who created Clojure, that talks about how easy is not the same as simple. Finding the simplest solution is not necessarily easy to find, but you can tell it's simple when you find it. The problem, of course, is a lot of people stop right there. And they check it in and say, okay, well, I'm going to move to the next problem. And the rest of the stuff, yeah, we can fix it sometime later if we get around to it. It's not important. Turns out it is really important. Because when you stop right there, you're creating technical debt. We got a fancy name for it. We call it technical debt. But of course, technical debt, my attitude about technical debt is, first of all, don't do it. Go ahead and finish off and get the code done absolutely gorgeous before you move on. It pays huge dividends. The second thing I say about it is, when you talk about technical debt, it's either one or two things going on. Either you're ignorant about how to do it, which I can forgive, or you're lazy, which I cannot forgive. It's either one of those two things going on. When I hear people say, well, we have to get out the door, my manager's pushing on me, yeah, about 1 time in 5 is your manager actually pushing on you. Most of the time you're pushing on yourself because you're tired of it, you want to get rid of it, you want to try to clean it up. Or you go into a code review and somebody's dropping in some really ugly code and you're like, oh, it's just a review, it works, I'll have to worry about this later. This is what creates the 13%. You want the 6x, you want the 4x, you cannot be lazy about these things. The other thing is we want to make sure we're separating our concerns very well. We want to separate out the model, the behavior of the business, away from the user interface and away from that persistence frameworks. And you got to craft that model very carefully. So most of the things I'm talking about is how I write really gorgeous models. Because if you get the model right, the business doesn't change that often. Businesses are amazingly stable in how they work. If we capture that logic associated with the business, we're in really good shape, especially if it's clean. So don't worry about these guys. That's what the controllers are for. You write ugly code here to keep the uglies from this guy away from my model. And when they come out with a different type of user interface, I'm going to put another piece of code in there to keep it away from my model. We call those controllers, we call them DAOs, but their job is to keep it clean. So let's talk about the model in particular. So in a typical method in a model, you sort of ask questions like, how big are your methods on average? When you're writing a method in your language, how big are these guys? And you hear numbers like, well, I kind of like to fit one on one page of my screen, so it's 25 lines of code or some size like that. So with the nationwide project, basically our average method was of 2.3 lines of code. In fact, our entire class is only 25 lines of executable code on average in the model. It had one job. It did that job really, really well. I have a colleague that worked in Smalltalk. His average was hanging around 1.1 lines. When we work in Kotlin, I think we just did a Kotlin exercise in the class, in a workshop for the last 2 days. I think our Kotlin number came out to 1.9, implementing some nice behaviors. So this is a very strange programming style, but again, very much encouraged by those rules and following those guidelines. And again, it's all been described. Now, where did this stuff come from? Well, Fred Brooks, who is a Turing Award winner, he actually wrote the 360 operating system, which sounds like a really important thing at this point in time, except it ran on a 64K machine. It wasn't that big of an operating system. But he had a theory about how this works, and it kind of influenced my early career when I was in IBM. And basically, the theory was you define your data structure very carefully. Because if you get that data structure right, the code writes itself. So you can surround this stuff with code. And this was the philosophy I grew up in. In fact, we actually had a programmer we would dedicate to owning the data structure, so that we had control over that thing to make sure it was constantly nicely organized. Of course, there was a corollary to this, which was basically if you change this data structure, all your code is now suspect, which means I got to test it all again, which is the process that drove waterfall in the first place. Because we basically don't want to test I make one small change and have to test all our code. No, let's kind of wait and test all of it at the same time. So let's take a little longer to make all our changes. And so basically waterfall is born out of this philosophy. Well, the good news is we have a new philosophy that came along. Actually came out of a guy named Dave Parnas, who actually worked for Fred Brooks at the University of North Carolina. And he basically said, you really want to do this thing called encapsulation. You really want to take the data and cut it into little pieces and isolate it from each other, so that only a little piece of code has to worry about each individual data. And we call this object-oriented programming. There's certain signs that you're not doing object-oriented programming properly. There's certain signs you're violating encapsulation. There's signs that you're basically trying to go back to Fred Brooks' model when you're writing your code. So the first sign would be you have public variables. You have variables that somebody can reach through and grab. This is not necessarily a good thing because that's kind of like you have all of the data available to everybody. So you're back to Fred Brooks and you're going to get stuck in waterfall. But that also means you can't let other people get to it indirectly through getters and setters. I had a student in one of my classes come up and say, my professor said encapsulation is really important. You should not have public variables. You should put getters and setters on everything instead. Of course, they have the same effect. You can get to all the data. I was working in India on a code base, 1 million lines of code at the time. And somebody had slipped in a getter and setter on a key value in one of our classes. And by the time I got to the code base, which was a decade later, there were 57 other classes using that data 83 times. There was no way in the world I could change that code. It was Fred Brooks' model all over again. And it was a nightmare to try to get that thing untangled. We never got it untangled. So we get rid of the getters and setters. If you need a getter and setter, you put in the code in the wrong place. If I need the information out of an object, go put the code with that object. Hide the data. Any class that ends in ER or OR are very suspicious. I'm a calculator. I'm the manager. I'm the director class. I almost guarantee you all your God classes end in ER or OR. And what do? They go get other people's data. Because they don't have a data of their own. That's why they're a calculator. Give me your data, give me your data, give me your data. So it's a sign basically you have one of those things. And I almost guarantee you those are the ones that are the biggest classes, the nightmare classes in your code base. They should not exist. Not in this school of programming. Data objects. What an oxymoron. My job is to have a bunch of data and I'm giving it to anybody who asks for it. There's absolutely no concept of encapsulation there. You can label that struct, same problem. If you need to build a struct, there's something about this data you care about. Then whatever that is, put some code around there that does the things you want to with that data. Don't give the data to the rest of the world. They'll use it. And finally, this sort of pattern you see in your code. A.B.C.D.E. It's called the law of Demeter. Because you're sitting over there and you're calling A, and calling this string, you know way too much about the entire object graph of your system. And therefore, you know way too much about things. And by the way, almost all these B, C, and D are giving you back their data when you make those calls. So those are sort of things you want to avoid. So in my model, you don't see any of this. We get rid of all this stuff in the model to get that 6x factor. We have certain statements we don't like. We throw these out. By the way, I was in the generation we wrote goto statements. And then somebody came along, a decade after I started programming, and says, we can't use goto anymore. I'm like, I might as well quit. There are 10% of my statements are gotos. How can I not write a program with a goto? I survived. But I've thrown some new statements out. Case statements, switch statements. No, get rid of those guys. Maybe once every 18 months I have one of those, and it's always in my glue code, never in my core model. Else is gone. We don't need else. Now, there are design patterns that get rid of that thing. We use those patterns to kill those else statements. Because the else statements create pass through our code. The more pass you have through your code, the buggier it gets. We don't have those. We get rid of the else statement. We don't like if statements. But we'll tolerate them if they're first. If there's a little guard clause at the beginning of your method to sort of make sure you're not doing something stupid later on, perfectly fine. An if statement in the middle of my method? No way. I get rid of those guys. Enums. Of course, what do you do with an enum except use a case statement? So we don't use enums either. They're gone. Enums are almost always hiding a class. Now, fortunately, in some languages like Java, enums have gotten so much new rich behavior, they're basically classes now. And if you encapsulate them properly, an enum's kind of okay. But we might as well be a class then. Then we throw some data types away as well. These are data types that should not exist inside your model. Not if you want the 6x productivity. First one is Booleans. What are you going to do with a Boolean? If statement with an else clause. So we get rid of the Booleans. We get rid of maps. Because what is a map except two pieces of data that are sort of unrelated to each other? I mean, here's a string and here's a number. They're not naturally friends. You're trying to tell me something about these. There's probably a class around there that you can tease out. And we will tease such classes out. Naked numbers. These are really dangerous. Here's 3 floating around. Well, what does 3 mean? I have no idea. Nice thing is that things like quantity patterns. Does 3 mean 3 miles? Does it mean 3 hours? Does it mean, 3 Canadian dollars? What does this mean? By the way, the department store Target, big department store in the U.S., moved into Canada. 100 stores opened. 6 months later, 100 stores closed. What happened? Well, it turns out they'd written their system in completely English-thinking metrics. So things were in feet, and things were in ounces, and shelves were measured that way, and everything was in dollars. And they moved into Canada, they couldn't handle Canadian money. They couldn't handle milliliters. They couldn't handle shelf length of centimeters. And they had exceptions. They would keep saying, oh no, ignore this system warning about this, ignore the system warning, until they had no idea what their stores had in them. They were losing money like crazy. They had to close 100 stores because the IT systems had written naked numbers into their system. They never thought about growing their system beyond that. So you're mostly Europeans, you know better than to put naked numbers into your system. There's all sorts of currencies out there. So we get rid of the naked numbers in my model. And of course, strings. Oh my goodness, you can misspell a string easily, and you never know what happened. So my goodness, don't use strings. Strings are good for user interfaces. Strings are good for database fields, but keep them away from my model. Use real objects associated with those instead, things that have real behaviors. So you can see basically a lot of this is these things you throw away out of your code in order to get this really gorgeous looking code. And it's not a natural way of doing things. The other thing we want to take is make sure we have a delivery focus. And sometimes we don't necessarily have this delivery focus all the way down through the organization. Yes, we know it's important to get our code out the door, but we don't sort of focus on it throughout the organization. So one of the things I like to do is I only count things that are done. So when a story is done, we talk about it's done. When a story is 80% done, it's not done. We only count things we finish. And even at a stand-up meeting, we have a stand-up meeting every day. You come in for your stand-up. You say, well, what did you finish yesterday? Well, I got 4 tasks done out of my story. I pat you on the head, we move on. When you sort of say, I got nothing done, well, we're going to have a discussion offline about what went wrong. Is it too hard? You're pairing with the wrong person? What don't we understand about this problem? But everything is focused on done. Because of that focus also, now it becomes much more important to finish something than to start something new. So we start again our stand-up every day and says, what on the card wall can we finish today? Because that's the most important thing we can have. So we don't bring these new stories in just because they look like they're fun or because some guy's putting pressure on me to start their process. I ignore that. We finish things that are on the ball first. Which also means bugs are my most important story every day. If I got a bug on the wall, that's the first thing I'm going to attack. I don't put it into a database. I don't put it into Jira. I don't park it for 6 weeks waiting for somebody else to fix it. It's the most important thing we're going to work on today. And I'll put my most important individuals who can fix that bug on that story first. Let's finish this bug off first and close the story out. Again, this philosophy sort of begins to permeate everything you're working on. And finally, of course, as I said, all my stand-ups are focused on what did you get done yesterday. I can run a stand-up with 50 people in 15 minutes because we're focusing on what's done and what's most important to work on today. We're not having all sorts of discussions about why it's hard or what your cat did last night or any of these other things. We want to focus on what's been done and what needs to be done today. The other thing I focus on is making sure we're constantly looking at how to enhance the productivity of this team on this project right now. I don't necessarily want to wait till the next retrospective to come up with a new idea. If we have a new idea, let's do it. But if I look at all the things you could possibly do, you look at things you can do with tools, maybe a better set of tools comes out, get some more tools, maybe you can do better with that. You get some productivity out of that. Maybe you get some better management process associated with that. Maybe yes gets better. But my biggest leverage has always been and will continue to be increasing the skills of the programmers who are at the table. And my favorite technique for doing that is pair programming. When we start on a project, I want to deliver that project and I want to have better programmers at the end. And the best way to learn things is to pair with somebody who knows more than you do. In fact, the job of my strongest programmers is to make more strong programmers. Not necessarily write more code than everybody else. And you measure them accordingly. It's pretty easy across that 8-month project, for example, to double the productivity of all my programmers. They were producing twice as many stories completed at the end of that than they did at the beginning. Because they'd been pairing with each other, picked up skills from each other. We had some very strong programmers. They made more strong programmers. It was a compounding effect. So when I put contingency in projects, my biggest contingency is here. Not putting 20% on my estimates or other things like that, is making sure I can make better programmers. If a client tells me I can't pair a program, I say, fine, I'm not doing this project. Because that kills my ability to make these skills. And I'm not going to take these guys offline for training or send them off to other classes. I can do this live and in place if I have the right programmers that know this stuff. They can teach it to the other people. Finally, watch out for the spreadsheet fantasies. Managers love the spreadsheet fantasies. You know, spreadsheets make a lot of sense if you're doing things like basketball tracking or box scores of baseball or things like that. But somehow managers think it also works when you put programmers into a spreadsheet across projects and you allocate them by fractions. And of course, as programmers, we know this is complete nonsense because there's context changes. And did you really work 10% on Project C, Paul, or did Jay work 10% on this or not? We have no idea. So in my projects, unless you're working with me all day, I don't want you. If you're going to dedicate today to me, if you come to my stand-up, you're taking an assignment for all day, you're fine as with me. If you say, I got 10% of your time today, I'm like, go do your other stuff today because you're worthless to me. You're only going to slow me down. And you push that hard enough, the managers finally get the hint that says, dedicated resource, at least for until I finish the project aggressively, is fine. Then, by the way, this is probably somebody who says, I got 4 projects running because I promised everybody we're working on it. You need to stop A and B and just finish C and D. Get on with it. So watch out for the spreadsheet fantasy. We don't let this occur. And then finally, the last magic sauce here is make sure you kill the fear. There's a lot of ways fears creep into programmers' minds. And you want to make sure you stop that because that stops the creativity, stops the innovation. So first of all, you're always afraid of how much does it cost if I fail something. If something doesn't work, what's going to happen? Is the sky going to fall or whatever? But also, people are worried about you're going to get fired if you do something wrong. So let's don't take any chances. I may get fired. I've seen organizations where this happens. People will get fired for doing something wrong. And guess what? They stop trying anything unless you signed it off, which means now it's your fault, not my fault. Fear. Of course, there's a lot of noise about estimates and the value of estimates, but estimates are a lot of source of fear. Imagine you do the traditional sort of stuff you do at a sprint beginning. I sit down here and here's a story. You're going to estimate the story for me. What is your estimate for this? Because you're going to own this story, dude. So you got to come up with an estimate. You say, well, if I have to pair with this idiot over here, it's going to take me 5 days. But if I pair with a smart guy, it's going to take me a day. Well, if I say 5 days, they think I'm an idiot. But what if I say one and I get the idiot? Fear. And of course, once we start these stories, you want people to help work on your story because you want your story finished, even though it may not be very important. And you'll say, trust me, I'll work on your story after you finish my story. All bad processes, all because I said, what is your estimate? What is your estimate for this? And of course, there's people saying you're not doing it the right way. This is the way we've always done it. We always use curly braces, and we always like blank lines everywhere. We like to do these things the right way. Another source of fear. This was a slogan from a pizza company in the U.S. I think it was Domino's Pizza. They had a national advertising campaign and said, failure is an option. They were trying different types of pizzas, and they talked about some of the really bad ideas they had. And it was okay. That's the attitude you want to have here. It's okay to fail. If you're not failing, you're not innovating. So we like this concept of failing fast. If you're going to fail, though, fail really quickly. That goes back to feedback. So you want to create this no fear practice. So when you do that, you wind up basically with the traditional Agile practices and roles. And these are the ones I follow pretty religiously when I'm doing my traditional projects. So I like stand-ups. I like stories, but my stories are really, really tiny. They're stories. They're not essays. Retrospectives for the feedback. Estimates We'll do estimates at the beginning of a project, but then we'll kind of slip them in. Iterations are nice for feedback processes, but we always almost go continuous delivery. And these others, you, of course, know about as well. And, of course, you have the corresponding roles. There are roles for developers and architects, people that understand the big picture. And I do want my architects to write code. So my architects do write code. But I need that skill in the room because I have to have people that think the big picture before I move on. And if you do this, you do get this sort of 6 times productivity. And I've always gotten this sort of numbers with my Agile projects. Part because I tend to own the process. I tend to require the pairing. We try to kill all the fear as it comes along, and those other aspects. So, example of handling in-project changes, going back to Nationwide again, we had our 8-month schedule, and there was, of course, the 12-month alternative from the Sigma Level 5 vendor. Well, as fate would have it, guess what? The customer changed their mind. In fact, when we got to this point, they changed their mind about 80% of the content of that next release. Now, if you're down here in the sort of the red zone here, and you're the traditional Indian company that did all your upfront design and architecture and handed everything out, if they come up with this change, you're going to say, okay, here's a change order you need. We're either going to do 18-month projects, or let's talk about release 2, which will be another $2 million, by the way. What was our reaction to this? Well, we had done nothing to accommodate those other 3 months of stories. They weren't played yet. And so there was no accommodation for those at all. We hadn't studied them. We hadn't put them into backlogs. We hadn't done designs for them. We'd done nothing about them. So we just swapped them out. We were perfectly happy swapping them out. And so we wound up delivering what they wanted, which was a different set of stories, primarily for that next 3 months, and still delivered exactly what they wanted on time. We could accommodate the change. All right, so that was kind of the story for the traditional problems. So again, good Agile practices work really well in this environment, but it's got to be the real Agile stuff. It's not kind of the half Agile things. And you got to be very aggressive in making sure you sort of follow those other things to get sort of the high productivity numbers that Jeff Sutherland talks about and that I've seen in my projects as well. Well, let's talk about the fuzzy guys. Now, the fuzzy guys are an entirely different beast. Remember, there's no experts anymore. So this kind of process of having stories fit into the team, we measure our stories, we estimate them. A lot of this stuff doesn't even work anymore. You can't, and you try to force feed that into this problem, not bad things tend to happen. So the first thing you got to realize is that you have to have a fuzzy vision of what you want to build. So basically, we need to move through this idea that we have requirements, that somebody knows what we want, and we can carve it into stone tablets. Instead, we need to move to a thing about we're trying ideas out. Because we don't know what's going to work. And we don't care where these ideas come from. They could come from the business, fine. They come from customers, fine. They come from programmers, that's fine. We don't care where they come from. The idea is how fast can you try out to see if it actually works. So this is an expression that we had in London at one of these companies where we did this. We said experimentation drives innovation. And I love that because experimentation by its very nature says we are going to try things and we will fail. That's why we call them experiments. And when somebody comes to us, and they came to me a lot in that environment, that says, oh, you had a failure there. We need some more meetings. I tell them to shut up. If he doesn't want to hear me say it, we go to the managing director. He tells them to shut up. We're going to try to go faster, not try to stop first, to go slower to get it perfect. Because fuzzy problems require you to go fast to figure these things out. So we're going to speed ourselves up. In this environment, by the way, one of the things we did was this was the age of VMs before we had Docker containers. We had little microservices running in this environment. We ran each one in its own dedicated VM. Yep, it's Java VMs, a lot of them. They can run multiple services very easily, and JVMs do that. We did not want to exploit that. We wanted complete independence of these services. We didn't want coupling. We wanted the speed associated with that. So we did a lot of things. We spent a lot of money to make ourselves go faster. So let's talk about some of the things we had to think about. First of all, we had to rethink our interactions. I call this the Agile, sort of the Agile requirements triangle. A colleague of mine, Greg Reiser in ThoughtWorks, and I drew this many, many years ago. We said here stories, and most processes have stories. We break stories into tasks, but we also said tasks are part of something bigger, sometimes called features or epics and things like that, which are part of our bigger project. And that's also part of some overall business initiative. And the really lovely thing about Agile is you can probably tie everything you do back to some business initiative, which is pretty cool. Because a lot of the waterfall stuff, that was very hard. But as you say, most processes are associated with stories and managing around stories. I mean, occasionally they drift down to task, which is kind of evil, but most people talk about stories as being the unit of metrics. In this world, you need to move up to features. The job of the customer is different. The job of the customer now is not give me stories. The job of the customer is to teach me your domain. What are the KPIs that mean success in your domain? What are we measuring? Is it, customer retention? Is it, how long do you stay on pages? Is it how many new logins I get? How many registrations I get? What is your metric for success? Tell me what that is, and then I can start measuring that as I experiment. So now the customer is going to interact quite a bit differently with me in this environment. We also want to exploit the fact I'm working on a fuzzy problem. Fuzzy problems have some things you can take advantage of. First thing is, most fuzzy problems are not associated with transactions. Fuzzy problem is, should I start loaning you money or not? Once I make that decision, loaning you the money is not a fuzzy problem anymore. That's a very traditional problem. I'm going to kick that back to my legacy system. Well, what book do you want to read? Here's some suggestions. When you say, I want this book, I can load that book for you. So it turns out transactions are relatively rare in fuzzy problems. We're kind of making suggestions. If the user picks our suggestion, then of course now it becomes a very traditional problem to deliver on that suggestion. Which also means eventual data consistency is perfectly fine. So I don't need to have that centralized database that's perfectly consistent or as close as I can get it. I can live with day-old data sometimes. In fact, you could have day-old data. I could have day-old data. Most algorithms work fine in fuzzy problems because they're fuzzy. I don't know what the right answer is. I'm guessing anyway. So you take advantage of that. And the idea also in a system that's supporting fuzzy problems, if part of the system is not working, and you're not getting necessarily all of the suggestions and sources of suggestions, some of it still is working. And so it gracefully degrades as services go down and come back up. But you can also improve the system, and we'll go into some aspects of that. This is really strange, because you're thinking about it, your centralized database don't need it anymore. Well, that's kind of like, that's heresy in many places. And then I have to worry about transactions. That's perfectly fine. Parts systems can fail and not be perfect. That's okay. Which means maybe I don't have to spend so much time testing everything and make it perfect. I can sort of get out there and see, make sure it tries to work. So I want to exploit some of these things as I move through that. So again, microservices tend to be well suited for this. It's my favorite solution for solving fuzzy problems. There are other solutions out there as well, particularly some of the new AI machine learning ideas. If you look at microservices, though, we're talking about real microservices here. First of all, they're really, really, really small. Generally, if it takes more than one person to develop and deliver this service, it's not a microservice anymore. This is Adrian Cockcroft talking about this. And Adrian's running around this conference, so if you get a chance to pin him down about this, talk to him about that. If it takes more than one person to write it, it's not a microservice. So when a team comes to me and says, I got 6 guys working on microservices, and it's going to take us 4 months to deliver it, I'm like, yeah, service, perfectly fine thing to have, not a microservice. You want these things very loosely coupled, because one of the things I want to do is deploy aggressively. It's about trying things out very quickly. Excuse me. Multiple versions. I want to be able to run multiple versions at the same time if possible. That allows me to try something out, an upgrade, and see if it works better, and turn off the old one. The web runs this way. You have multiple versions of these sites running at the same time. Services are responsible for monitoring their own behavior, because it's kind of a self-organizing system. To some degree, chaos engineering is built into these systems. This we stole from Google. Basically, if you do something interesting, you want to publish it so people can see it. That way, if I have an idea about something I can try, all the data is already available to me. I don't have to sort of go 16 places and 16 other places to get it, or negotiate with new APIs with you. I can try ideas out aggressively. This is what Google did. This is why they kept refining their systems so aggressively, was they were publishing events about everything, even though they didn't know what somebody might use it or not. And finally, application kind of boundaries, that's kind of gone away. Now, if you look at sort of how you sort of classify systems like this, I drew this chart, which is basically a log-log scale, which says how many lines of code your system is and how many services you have, how many entities you have in that system. I sort of call this the Rails and Java zone. You can put C# in here too. But this is kind of the one big system with lots and lots and lots of code, the monolith, so to speak. Then we broke that up into, 10, 15 years ago, we started breaking that up into smaller pieces, but still quite large. I think Credit Suisse was one of the early guys in this space. And they broke their huge monolith into 50,000 line of code segments, by and large, which I can sort of understand and get my head around. But then the microservice guys came along, and this is kind of where I parked those guys. It's still a service-based architecture, but they're much, much, much more numerous and much, much, much smaller. So I'm going to show you an animation in a few minutes that talks about some of these. I worked on projects like here. I'll never do that again. Life is too short. I have an animation we'll see in a minute, and that's kind of where that fits when you flesh it out. This was the company I worked with in London. We had over 300 microservices, none of which were over 100 lines of code. There's Netflix. Massive system made up of lots and lots and lots of very, very small services. So we say people are saying they're doing microservices. A lot of the guys are parked over here, which is a perfectly fine place to be. It's just not the same as the microservices for fuzzy problems. So this is the analogy I like to use. I drew this picture with my finger on a new iPad flying across the country, so I don't apologize for the artwork. But one of the things you'll see here is, up here with every event buses are key here. We're getting rid of the operational SQL database. If you look through Silicon Valley, by and large, the thing is gone. It's been replaced by an event bus that says if this is your email address today and this is your email address tomorrow, these are both perfectly valid data points. We want to keep both pieces of data. In fact, the change is probably interesting in itself. So we will put everything, and in my world, we like to put everything on this same event bus. That's why I call it a Rapids. It's got all the messages on there from all the services, but it also has all the log messages. Of course, logs messages are things that are interesting that happen, that you want to tell people about. Put it on the event bus. Traffic stats for your various service, put it on the event bus. User journeys for your pages, put it on the event bus. Then we cut these into smaller pieces called rivers, which are basically subsets of this stuff. And again, we create that with a microservice. We pull off a subset of that, and that's where we attach our services. But you also have a need for entities. Entities haven't gone away. They're still really good for reporting. So kind of the reporting database you have, or the data warehouse, still a very important aspect. And by the way, SQL databases do a very nice job of that. But the way you handle that is you're basically looking for these events on the Rapids with a microservice, and you turn it into a CRUD transaction, and that'll keep your database up to date. So this creates a need for a high-performance event bus. So Kafka's out there now. It's being used quite a few places. I've been talking about this for quite a few years now. Of course, this is almost standard. And of course, there's some other event buses out there. Kinesis is on Amazon right now, another event bus. And there's several others out there. But they all have the same trait, and that is they have enormous capacity. Kafka bus back in the day could handle 250,000 messages a second, which is more than enough for the type of applications I tend to work on. Maybe not if you're LinkedIn, where you came from. And again, Kafka bus has been used for over a decade. It's the core behind the business of LinkedIn. So it's very reliable technology. But when they say 250,000 messages, they're cheating. Because one of the things they talk about messages is, if you write the message one time and read it 100 times, that's 101 messages. And so if you have 100 services on there, you haven't got 250,000 messages per second, you're down to 2,500. Maybe not enough after all. So you want to try to minimize the attachments to your Kafka bus. You do that by building yourself another microservice that kind of streams off a subset and hands those to the services. And so I tend to attach only these sort of second-tier guys. And again, I label these ZeroMQ because that's my favorite library for this. Allows easy attachment from lots of languages. But it doesn't do queuing. That's why it's called ZeroMQ. The queuing is handled by the Kafka bus. Now, when you put this together, you basically attach your service to one of these rivers, but you always publish back to the Rapids. You don't publish back to just your river. because that means nobody needs this message except your own guys on the river. You're not that smart. You're not accommodating the change in the future. So publish back to the rapids. It has lots of capacity. Don't worry about it. Now that creates the concept for asynchronous services. And this is one of the things you hear talked about microservices that you have to worry about. And it is something you need to design around. Asynchronous services. Here's one we call the need pattern. Here's a service sitting here. He expresses a need to the bus. Maybe something like, should I loan you money? Now, I don't know who's listening for that. In fact, I have to worry about that case that nobody's listening to me. So whether there's a timeout or some default behavior here, I have to worry about that situation. All right, in this case, I got a couple of guys who are listening for that. The blue guy is listening for that. He looks at your bank account, sees what sort of transactions you have, notices that, for example, you got regular deposits, probably means you have a job, and it never goes negative. So feeling pretty good about it. So he says, yeah, that's a good idea. The other guy could be calling a service bureau. Service bureau API. See what the service bureau thinks of your credit rating. And they vote. They said, these are what I found. They might veto. They might have some other protocols like that. This guy collects the answers and decides whether he wants to loan your money or not. So the really nice thing about this, if I have a new idea for a better blue service, I can create it, bring it up. I don't have to tell this guy about it. I don't have to tell anybody else about it. I can just bring it up and try it. See if I'm getting better results. But also, if the green service goes down, I'm still getting answers. Now, maybe not as good of an answer, but it's a fuzzy question. Even when everybody's up and running, I don't know if he's ever going to pay me back. They're fuzzy problems. Take advantage of the fuzzy nature. So here's an example of this sort of system in action. And we built one of these for one of our clients. This is called an offer engine. The idea of an offer engine is you want to try to get a customer to buy more from you than he intended to. So he comes to your site, see if you can sell him more than he came for. Or he's calling you on the phone. Can you sell him additional services? Can you give him upgrades? Can you get something to do this? Or can you do something to sort of sweeten the deal to make sure you close the sale? Because sales by their very nature are very fuzzy transactions. And once he says yes, very traditional. But giving him options to say yes, fuzzy problem. So let's say I have a legacy system, and that's what the customer had in our environment. He had a legacy system. We wanted to sort of put some advertising on that web page. So we put ourselves an event bus in place, put ourselves an offer, something to interface to the bus. So it says, here's a page that came up. We hooked into the legacy system to put an event on this bus for us. And we had a couple of services that would generate offers. This was one at the corporate level. So corporate has some plans associated with this, some promotions they want to push. They would have an idea of an offer. But each individual rental location had their own issues, surplus of vehicles or scarcity of vehicles. And therefore, they wanted to make different offers themselves as well. So they would compete for the attention of this user, but they don't know about each other. You can also do other things like enhance the information you're getting. For example, if they're a member of your frequent renter program, you want to give them a slightly better deal. It turns out the reason frequent renter programs exist is you want to find out who your regular customers are. Because holding on to your regular customer by giving him a slightly better deal is much cheaper than trying to win him back. Winning a customer back is a very expensive proposition. So membership. And segmentation is classifying your customers on how they behave. For example, in the rental car business, if you rent between Monday and Thursday, chances are you're a business traveler. A discount coupon is not going to entice you to rent. But how about some points or an extra day for free in the weekend? On the other hand, if it is a weekend, it is your money, discounts are very important to you. Just looking at historic usage of the system by that customer, I can make some hints about good ideas. All right, so a web page comes up. I'll put a message on the bus that says, here's an opportunity for to put some information in front of a customer. Now, this message will flow to these guys because they don't care, but these guys, until I know who it is, I can't look this information up. So their river doesn't get a message. These guys have ideas about solutions. They publish that solution. This guy collects those solutions off the bus because they're answers to the need. And we do a redirect and put the information on the page. Okay, so now, turns out Sally logs in. Okay, now we know who it is. Now it gets a little more interesting. So we put another message on the bus. It's got a little more information in it this time. In this case, everybody's interested in this. And of course, all this is happening in parallel. This is a pub sub bus. So these guys say, well, like Sally's an existing member. For existing members, I have slightly different offers. Pushes those onto the bus. This guy collects them. Meanwhile, we look at that and say, Sally, oh, Sally is one of these platinum level users. She's one of our best customers. She spends lots of money with us. We put that on the bus. So we add that to the original request and say, by the way, Sally is a platinum. Again, that message gets captured by everybody else. These guys say, wow, platinum user. Well, for platinum users, I have this really good deal because they know we want to keep her as a customer. They put the information back on the bus. Similarly, by the way, segmentation would basically say, yeah, Sally's a road warrior. We put that on the bus. The services would say, road warrior, well, that discount coupon, yeah, that's a really bad idea. How about this idea instead? And we keep doing that and collecting all these solutions and eventually pull them up and choose the best set of solutions we like. So one of the characteristics of that is there's lots and lots of messages flowing. And I don't care. These are high-capacity buses. Again, we are erring on the side of how fast can I try ideas out. This sort of system lets me try ideas out very aggressively. So if you look at services in that environment, I'll have a different interface to each of my channels. For example, if I'm working with IE6, I'm going to have something sitting there for 200 milliseconds, pick the best answer and push it back. If, on the other hand, my browser supports WebSockets, I can push these answers as they come in. So I can be much more aggressive in how many I push out there. We do the same thing if I was doing an iOS or Android device. I push my JSON out to that device as it comes in. We actually also ran this system for our frequent renters. Once a month, we'd send them an email. We run this same system and pull up 7 different offers and put them on our email page and send that to that customer using the same engine. But a different microservice making the request, waiting a different amount of time. Finally, from the needs side, you have the processing of solutions. So this happens. So basically, in this case, you publish the need. These enrichment services like segmentation and membership enrich the packet and republish it back on the bus. These other guys, solutions, actually provide real solutions. But we have a concept of client biases as well. Let's keep track of what we showed Sally. If we showed Sally an SUV ad 4 or 5 times and she hasn't clicked on it, we want to degrade that likelihood of showing that to her again. So when that little contest comes up about what we want to show Sally, we want to score that ad poorly so that we get a better answer. And solution blockers say, oh, by the way, Sally already has renting something in Houston. Don't give her a discount in Houston. She's just going to call the call center up and ask for her money back. She's already agreed to the deal. Let's keep the money. So these become solutions. And of course, the nice thing about Event Bus is you can log and see what's going on. You can monitor certain behaviors. And in particular, you can build really interesting KPIs. Whatever the KPI is that you measure your business success on, you can pull that off the Event Bus. And that gives that customer, gives your users the feedback. And in fact, gives your programmers the feedback that says, here's something I tried. Is it working? Here's something else I tried. Is it working? When we did this in London, we were doing it with Google advertising. 20 minutes after you put a Google ad up there, you get feedback from Google about how good it's working. That's powerful. The internet sales, fast feedback. Powerful. So for certain domains, particularly fuzzy domains, this actually is a very powerful architecture for trying things out very aggressively. It also allows you to sort of build these incremental applications. So remember when I talked about Nationwide, we put out a release after 3 months, and then after 2 months, after another 3 months. We felt really good about ourselves. Well, in this sort of environment, you can make these changes almost hour by hour. So I can bring up this initial system just by having a couple of people making offers, and I got a system is up and running. Then I can add the next day, I can add some more enhancements about membership and segmentation, refine a little bit more, making more money. And you keep refining it, refining it constantly. So your ROI on these systems is very, very high because you get the system out very quickly and you're enhancing it all the time. So we don't talk about putting a release out every 2 or 3 months anymore. We talk about how many times we're changing this a day. how many ideas we can try out aggressively. That retailer in the UK I talked about, they're trying things out in their system at least twice a day. They're putting new things out there into their stores, trying it out that frequently. So this kind of comes up with kind of what I call reverse Conway's law. I don't really believe in Conway's law because I break it so often, but I kind of like reverse Conway's law. And I'm not the one that came up with this. I think some of my colleagues in microservices talked about this. But whatever your architecture is that you want to go with sort of a microservice fast delivery architecture, your team structure needs to be modeled after the architecture. If you're doing microservices this way, your teams are going to be small, 5 to 6 people at most. They've got complete autonomy to deploy what they need to deploy all the time. So DevOps is built in there. Cloud is built in there. Docker containers is built in there. They're making architectural design decisions on their own, and they're doing it live. There's no people signing off on this thing as we go. So that's the direction you want to go in. So some of these microservices, it doesn't take very lightweight it takes a very lightweight framework to sort of make these things work in event buses. I don't need a lot of strange architectures or magic frameworks to do asynchronous microservices with an event bus. So this is from a workshop where basically we have the idea of rapids, rivers, and ponds. And this is how you basically set up a service. You go to the service and basically say, I want to do a service. I'm going to be a river listener. I'm going to listen on a river for messages. I set up my connection to a rapids. In the class, we use RabbitMQ as our queuing system rather than Kafka, partly because I can run more RabbitMQs on my laptop. So you basically set a connection to your rapids. You define your river, and you define what you care about from your river. You say, I want the river. I want only messages that say, I'm looking for this sort of message. This is my home automation system. I'm looking for it to be a source being a Hue light bulb. And I want to know what the current state is, the light count, and the version. I want those fields. If these fields are not in that message, I don't care about the message. Don't give it to me. And then I say, basically, start me up. And then I either get called in one of these two APIs. Either I get invoked here, if I find a message that meets this criteria, I get invoked right here. And it gives me the message that meets this criteria, gives me that packet in particular, and tells me any other things that might go wrong with it. And it gives me a quick connection to the rapids, so I can respond to this. So in this case, I can just put myself a new message on there or change the message a little bit and republish it. 3 or 4 lines of code and I'm done. If you think about those microservices I show in the animation, they're simple. Each one is pretty simple. Are you a platinum member? Let me look you up in my little table. It's just key value store and put it on the bus. Now my job is done. It's easy to write these services. The error thing is just in case I want to debug it and find out why this message, I didn't want this message, I can look at it here. And that's basically all it takes to get going. So we run this microservice workshop, we actually implement that example from the rental car. And in about 2 days, we can implement a full implementation of that architecture. We implemented a system like this for one of our clients. It was obviously a little more complicated than that. We charged them $6 million to develop that system. It wasn't that hard. But that's okay. They made $40 million additional revenue in the first 6 months off that system. Fuzzy problems are where the real money lies. Not solving traditional stuff. People have already got their checkbook balanced and all this stuff has been done before. There's no excess profits there. Profits lie in solving fuzzy problems. So what happens to my process in this environment? Well, if my Agile process was all these other things, when I'm moving to this microservices world where we're talking about basically complex problems in a Cynefin model, fuzzy problems. There are no experts. So a lot of things actually fall away. For example, to some degree, we kill off the concept of stand-ups and story narratives, retrospectives, and estimating. Because frankly, most of my projects are lasting 4 hours and have one programmer on them. That's all it takes to run an experiment. So we don't have a lot of ceremony around that sort of thing. And by the way, if you have a new idea, something to do, I don't wait for a retrospective. We try it now. This is an environment where I can try ideas out today. I don't wait for my retrospective to have an idea. Of course, then iterations and mandatory pairing go away because my cycle time is measured in hours. When I was in London, basically, it was literally the average programmer pushed to production twice a day. Twice a day. We got rid of these things because basically our system was, first of all, these microservices are really, really small. In fact, a lot of times they don't even have an if statement in them. So the question is, what would you write a unit test for? Well, it's kind of like I'm testing what? The fact that I can write this code? And by the way, if you can't write 100 lines of code without making a mistake, you need to find a new career because you're not a programmer. So it turned out unit tests fell away. And it did acceptance tests because basically we could test in the live environment. We could deploy into production. In fact, we literally would go from notebook to production. There was no staging server, no testing servers. Notebook to production. Fuzzy problem, rules are different. Continuous integration, we went continuous delivery. What does the CI mean? CI is ancient. We're doing continuous delivery. And again, we ran into things in different virtual machines to isolate them from each other. Event Bus does a lovely job of isolating. With event buses, you don't need to do registration of services, which is how do you register a service? How do you register the second version of the service? Don't worry about that with event bus. I'm just talking to the bus. Very powerful for that. But it also turns out, I'm going to skip the parable of the Coke can. It's a really wonderful story. By the way, it comes from Womack and Jones. But we did this in practice. This was a project we worked on as a fuzzy problem. This was, in fact, which telephone plan should I switch you to in the UK? Turns out there were 1 million variations of telephone plans in the UK. 1 million. And so we're trying to help you find the right one. So this was our spreadsheet associated with that, and who had what role. Dave was the manager. I'm the Fred, but not the George. That's somebody else. George was the tech lead. I was one of the developers along with George, and Paul and Sarah were both developers. Jeremy was our business analyst. That's what the official titles were. What really was going on? Of course, testing was done by both the customer and by our project manager, Dave. All of us were kind of running the project. I run projects as well because of my experience. I was also kind of took the tech lead, especially with UI design and the like, as well as Paul. I did the UI design. Matt helped with the UI design, so I was kind of the UI designer for that as well. We were all kind of analysts in terms of figuring out what needs to be done next because we're all coming up with ideas. It turns out we were so good at coming up with ideas that, in fact, Jeremy rolled himself off the project. He wasn't needed. I don't need a separate business analyst. You guys understand the problem. We're talking the lingo. It's kind of a fuzzy problem. He wasn't necessary. So this turns out what happens when you have really fuzzy problems and how you want to organize yourself. Much flatter structure with kind of like the titles being completely meaningless. So what does that mean for basically your roles in a fuzzy problem? Well, obviously the BA and architect and Scrum Master and QA and managers are all useless. So they're gone. It's not because they're not skilled in what they do, but what's a manager going to do? He can't tell you how to be more successful because he doesn't know either. So unless there is sort of a need for a leader to sort of help you figure out things, or somebody is having personnel issues, yeah, it's nice to go to somebody, but it's not a full-time job for a project of this size. So you wind up with just 2 roles. Customers who have problems and can teach you what the problem domain is, and people that can implement ideas. So you can see how we squeeze ourselves down to that, just yellow guys running around this circle. And to some degree, a customer could actually start writing some code himself. So actually, it is quite a heterogeneous sort of organization. How fast can you go? This is that company in London. This is our GitHub stats for a particular week. We deployed 652 times with 53 developers. That averages out to basically, missed it. I didn't put it on the slide. This averages out to 1 new deployment every 3.5 minutes. Every 3.5 minutes, we were changing our system. 1 year, we had 50 employees. We made 50 million pounds that year. Solving fuzzy problems, competitive advantage goes to how fast you can do this. We were killing our competition because we were faster than they were. Because we had ideas. I'm sure they had ideas. We could get our ideas out today. They had to wait for their spring release or the fall release or the next spring release before IT could get in there. So this is how fast you can work in effective. I'm going to stop there because it kind of leaves about 10 minutes for questions and comments. But this is what I call chaos development. An ability to handle changing requirements constantly. And I gave you 2 different processes. if you have very traditional problems, extreme programming, Agile really carried out as true Agile, is actually very effective in doing this. See Jeff Sutherland, see some of the stuff that ThoughtWorks does, see some of the stuff that I've done in the past. On the other hand, you're working with a fuzzy problem, you got to think about these microservices, asynchronous microservices in particular. Tiny, tiny little guys, event buses. Take a hint from what's going on in Silicon Valley. It's a different style of architecture. And for all means, make sure you kill that centralized database in your microservice world. It will kill you. With that, let me wrap it up there. Thank you for your time and tolerating the weather and the rain. And I think we move to questions. Thank you.
Wow, thank you so much. Oh, I'm not falling this time. So the first question comes from Stefan again. Thank you, Stefan. If you could change one thing in our business, what would it be?
Ooh. I have to understand whether your business is doing fuzzy problems or not fuzzy problems. But I would say the first thing you'd probably want to do is sell the executives on the idea that frequent changes is something we can tolerate. So they can begin to tolerate that, I can put the rest of the process in place. If you try to do some of these things I'm talking about at the grassroots level, there will be people above you who will stop it. It's too strange for them. You need to convince the guys at the top there's something magic here that you're trying to pull off, and sell it to them in the business terms.
Thank you so much. Are there any further questions, maybe? Well then,
Good.
Thank you so much for your talk. I have the feeling that I have to go back and do things. This is one of the messages I'm taking away. Oh, and there is one more question. Idea, you should adapt your example to how fuzzily promote election of Trump for maximum impact. Okay, that's not a question.
I do find I do pick on Trump a little bit because if you go back to the Cynefin model, politicians typically are sitting in that simple sort of side. They think all problems are simple. You like me, I'll solve it. I'll build a wall, it'll fix our problems. And of course, the problems they're really trying to solve are complex. And so there's a huge mismatch between attitudes about things they say solve problems and actually the problems they're trying to solve. And of course, anytime you have a mismatch across the Cynefin model, you know you're going to fail miserably. Can use KI development in non-web applications? Oh, absolutely. Back-end applications love fuzzy things. So you think about what's running in the background of things like Amazon about figuring what sort of products you might want the next time you do that, or what to put on your page next time you see something. But yeah, I would say, and a lot of your AI stuff is all back-end off as well. And all your AI problems are basically solving fuzzy problems as well. Book recommendations. I would say if you're trying to develop in traditional XP stuff, I would say go grab Martin Fowler's Refactoring series. It would be the first book you'd want to read. So go grab that book, read that. It's got a lovely chapter in there called Code Smells that was written by Kent Beck. And it talks about what ugly code looks like. But the nice thing is in that chapter, when it talks about something as ugly, it puts the page references for here's the recipes in the rest of the book that fix that ugly piece of code. You want to leave that book in your lap until that book is in your head, so that you don't write that code that way, or if you write that code, you know there's a pattern to fix it. That will probably increase your productivity on the order of 3 or 4 times right there alone, having that information in your head. So I would say Martin Fowler's Refactoring book. So pick your choice of volumes, the Java one, the Ruby version, or the new JavaScript version. For all intents and purposes, they're very much the same.
And how do you distinguish between complex and just difficult problems? To
some degree, and again, I want to defer tomorrow morning to Dave Snowden talking about this, because he's much more elegant about talking about this. But to some degree, you have to watch how a problem behaves. So if a problem, if this event happens and this result happens, and this event happens and this result happens, and this event happens and this result happens, chances are it's complicated, because their cause and effect relationships seem to be related. Well, if this happens a couple of times and all of a sudden the opposite happens, you might be complex. So the problem is, and I think you'll talk about this, most of the time he calls problems in disorder. I'm not sure what part it is. Maybe even 85% of the time, his problems are disorder. He's got to watch how it behaves before he figures out where it slots in. Now, things that are obvious, like what book you want to read, that's a very fuzzy problem. What's your bank balance? That's not fuzzy. You let him know what that number is. So some of those are very easy to distinguish. But most of our business problems may be in that sort of disorder area. And you have to sort of figure out what it is by watching how it behaves. And then you want to organize yourself around it accordingly. Good.
Any further questions? Thank you, Dan. Thank you so much, George, for your talk. This is like a little something, celebration of craftsmanship. Thank you so much for participating in the conference.
Well, thank you.
And a round of applause to this wonderful talk.
Thank you.
Thank you.